Camera sliders, they're awesome, but unless you're happy with pushing the camera around by hand, they are really freaking expensive to buy when you want them motorized. And it's pretty hard to find when it does the things I wanted. It should be really smooth, it should be usable for both short video clips and time lapses over multiple hours or days, and it should be reasonably large. In my case, a 1 meter length sounded about right. So I designed and built this one from scratch using some electronics from a 3D printer and of course 3D printed parts. The results are pretty fantastic, I'd say, and you too can build this exact same slider for less than 60 bucks. Now, there are a few different options of making a slider like this, both when it comes to the mechanical parts and how you can control it. You could go with a true sliding setup, like with Egos bushings or even just some felt pads on a pair of pipes, or with a roller style axis like I have here, or even do a full-on linear ball bearing setup with these linear rails. Each one has its own advantages and disadvantages for smoothness, robustness and price. I settled on the open build system since linear ball bearings are quite sensitive to dust and dirt and will always have a bit of sticky lube on their guides, while sliding blocks don't care about dirt at all, but do have a bit of stick-slip friction, which isn't the greatest thing for those super slow moves. In my case, this is 20 by 40 mm open builds compatible V-slot with regular sized wheels and the big plate for maximum flexibility later on. I do want to add something like a motorized pan at some point. For electronics, I went with a stepper motor plus a driver, etc. I specifically picked the stepper motor instead of a geared DC motor since the stepper, first of all, is much more consistent in its move speed, but also allows those super slow moves that would require an insane amount of gearing with a DC motor. Star of the show here is the Arduino with a touchscreen and a click wheel encoder. As much of an all touchscreen interface would be super slick and all, having that haptic control element plus the click for stop and go just feels so much more direct. Touching the touchscreen only sets the direction, but there is obviously room for adding a bit more functionality there. This interface was already quite tricky to program with my limited coding skills, as the screen I'm using is rather slow with the Arduino, and just having the total runtime update as quickly as possible to make the click wheel encoder a bit more responsive required the use of, let's say, a few tricks. The mechanics actually started out as a non-motorized slider with the option to upgrade later on. On one end, the slider has this aluminum flywheel that is essentially just a scrap part that I had picked up a while ago, and that really helps with getting smooth slides without a motor. But now that I've upgraded it to be totally controlled with the Arduino, it's not really necessary anymore. In fact, I can sometimes see it introducing a bit of resonance in the movement with medium slow moves. On the other end, there is the motor mount that doubles up as the belt tensioner, and each end has these extra ball bearings to guide the belt so that it doesn't rub against the V-slot or anything else. So the other two printed parts are the Arduino and LCD mount, as well as the Sony NP-F battery mount, which is the de facto standard battery for smaller video equipment like this. The printed parts aren't the greatest designs and do require some support material to come out right, so if you're making improvements to the design, please do share them. On the back, I simply put a small breadboard to hold the motor driver and the voltage divider that allows the Arduino to monitor the battery voltage. A soldered proto PCB would have worked just as well and be a bit cleaner, but I wanted to stay flexible and open for experimentation. So let's build this thing. So starting at the ends, the bearings at the idler side are simply pressed in, if necessary with a bit of heat, and the piece of 8mm rod gets fixed in place with the pulley's screws. The extra bearing also simply gets screwed down with an M6 screw, as the printed parts already come with the proper relief cuts on the back, but do need the thread tapped by hand. If you don't have a matching tap, you can also just heat up a screw and use that to form the thread. Same on the other side, where you have the pulley on the motor itself, which needs to line up with the bearing, and then the motor gets clamped down with these long M3 screws. Next up, we'll need to mount whatever tripod head you want to use to the moving plate. In my case, I used a simple ball head to quickly adjust the camera angle and these 3 screws instead of the 1/4 20 thread to mount it because it was just easier to do. But you could just as well go down that route with the tripod thread. It just depends on the exact head you want to use. Now would be a good time to cut the belt to length. Mine is 7 feet and 1/4 inch or 2 meters and 14 centimeters long. The belt gets trapped in the printed belt holder before adding the open bilts plate and then gets screwed to that plate. This was the trickiest part to design since space is really tight and it does require a bit of trial and error to get it perfectly aligned in the slot without rubbing. The last finishing touch is the mounting plate, which you'll use to attach the slider to your tripod. I used a cheap Manfrotto compatible plate, drilled a few extra holes and mounted that to the bottom of the track, but there are other, maybe more elegant options available. The most important thing is to use a good and sturdy tripod. I've got this 9001 model with the Manfrotto head, which is plenty strong for the setup. The electronics are fairly simple too. If you don't want to use a battery, you can simply power the entire thing through the barrel jack on the Arduino with a 12-volt supply. But to prepare the battery holder, grab a pair of these 2.6mm mini plugs, get rid of their plastic bits and solder in a wire in the back. Then simply superglue them into the holes on the holder and maybe use a battery to align these while the glue sets. The wiring for the slider is really simple. The screen just pops on as a standard Arduino shield, taking out the largest portion of the work. The rest of the connections are battery to V-in on the Arduino and the stepper driver's input, ground to ground everywhere, 5-volt from the Arduino to the encoder and stepper driver, as well as its MS pins to enable 1/16 microstepping, and to the inverted reset and enable pins. I also connected the battery's voltage to analog pin 15 on the Arduino using a 2-to-1 voltage divider. Digital signals are step and direction for the driver, connected to pin 52 and 53, as well as the encoder's pins go into pin 19 for the button, and 21 and 20 for outputs 1 and 2. All in all, one of these mini breadboards is enough for everything and it allows you to swap in different drivers or extend the circuit later on. I use the standard A4988 Pololo style driver, which is more than enough for the job, but of course you can go with a dynamic driver if you want it extra smooth. Upload the firmware to the Arduino and you're ready to rock. So now that it's built, how do you use it? So when you start it up, the slider will be in the stopped state. As you turn the knob, you can adjust the time the slider will take to run the entire length of the track. That's what it displays, plus the speed it's going to be going at. If you just want a slow, steady sliding shot for close-up video, the minute range is a good start, but for larger objects you are going to need motion that is a lot quicker. The software has reasonable limits built in for how fast the slider can move, but it doesn't have end stops or any other safety measures, so you have to be somewhat careful when using it for that. You can quite easily do manual slide and pan shots, either by panning the slider's head, which still has your camera moving along a straight line, and that might be an interesting effect, but is going to cause issues with focus, or pan whatever tripod head the slider is mounted to, which actually gives you a movement that is much closer to a circle if you keep your object centered in frame and the camera perpendicular to the track. Of course, you can also use it for dolly zoom effects or vertical slides that look like jib shots, and whatever else you might come up with. The most interesting bit for me though is creating those super slow motion time lapses that are impossible to do any other way. For this, you should definitely check the start and end points and adjust the sliding time accordingly. If you're going to use 1/3 of the track's length, set the total runtime to 3 or 4 times of the total time you want that section to take, and you should be good to go. Here's what that's going to look like. Don't forget to plug the slider into a power supply, as even the larger MPF batteries will only last for about half a day. Most cameras have an interval mode built in. Use that to have it take pictures with a consistent timing, or alternatively plug in an external intervalometer. Most cameras allow you to create a video file straight from the time-lapse images, but you can always bring them into your video editor of choice. Now, if I were to build this thing again, the only two things I'd really change would be the electronics mount, to make everything a bit cleaner with fewer wires dangling around, and maybe try and find a different way to mount the belt, because right now, even though it works great, it's just really fiddly and just feels like it could be done better. Again, if you want to build it or make mods to the setup or software, I've released all this as open source. You can find the links in the video description. If you do build one, I'd really like to see it. Tweet it at Toms3dp, and even if you don't build one but still learn something, give the video a thumbs up. If not, leave a comment on how I can improve. Also consider subscribing to the channel and do click that bell, or YouTube might not show you updates as new videos come out and live streams go live. Check out the affiliate links from the video description below, or head over to Patreon to support the channel and get access to monthly Q&A hangouts and more. And that's it for today. Thanks for watching, and I'll see you in the next one.